Hello everyone, hope you all are doing well. So today we are going to do the next topic of our geography series, and the topic we are going to cover today is conventional current theory. So in the yesterday's video we have already done continental drift theory, and today we will be doing conventional current theory, and the coming theories, the remaining theories will be done in the coming lectures. So let's complete the conventional current theory. But before starting, I must let you know that please do make notes, because the notes you will make will help you immensely to revise, okay, to revise the subject, and that will be very helpful to you before the examinations. So please start. So let's start. So conventional current theory. So it was given by Arthur Holmes. Arthur Holmes in 1929. Plate tectonics, continental drift theory was given by Alfred Wagner in 1915, and conventional current theory was given by Arthur Holmes in 1929. So, what is this theory? So, this theory this theory successfully explains forces responsible for drift of continents. For drift of continents. You see, in continental drift theory, the forces told by Alfred Wagner were the tidal force and polar fling force, which was not largely accepted by the geographians. For most of the geography expert, it was that the polar fling force and tidal force do not create that much amount of force for the to make the continents to drift apart. So uh, that was one limitation of continental drift theory, which was covered by this theory, which explains the forces responsible for drift of continents. This theory is also used by plate tectonics theory. This theory is also used by plate tectonics theory, which we will discuss in the coming lectures. Plate tectonics theory to explain plate movements. To explain plate movements. Now, according to this theory, there are magnetic movements occurring in cyclical direction. There are magnetic movements occurring in cyclical direction within within mantle. These movements are termed as conventional currents, and these movements are termed as conventional current. So what it says that there are magnetic movements occurring in cyclical direction, that is like a cycle, okay, within the mantle, okay, and these magnetic movements are occurring in the mantle, and these are only known as conventional currents. So these conventional current includes includes three parts. So let's take another page to discuss those three parts. Conventional current, three parts. So the first part here is hot rising plumes of magma. Hot rising plumes of magma. It rises from core mantle boundary to the asthenosphere. It rises from core mental body to asthenosphere. Just right now we will explain after writing with the help of a diagram. Then you will be able to understand all these things. Asthenos, asthenosphere. So the hot rising plumes of magma is rising from the core mantle body to the asthenosphere. Now the second one is the sinking cold plumes of magma. First one was the hot rising and then sinking cold plumes of magma. So the sinking cold plumes of magma, it rises from asthenosphere. It goes from asthenosphere to core mantle boundary. So it sinks from asthenosphere to core mantle body. Now the next one is the lateral plumes of magma. That is, it moves along the asthenosphere. Moves along the asthenosphere. This is E and this will be O, asthenosphere. Okay. So these three only explains the conventional current theories. So let's see what happens in conventional current. So suppose this is our earth. Okay. Let it be this is our earth. Let me get better diagram. So this is our earth. So this will be the outer core. Outer core, and above the outer core we have inner mantle. So what happens? There are rising, first of all there are rising hot plumes of magma. So this will rise from, let it be here. These are number one. And number one is rising hot plumes of magma. Then there will be some sinking cold plumes of magma. Let it be here sinking. It is sinking from asthenosphere to the inner core. These are rising. These are rising. And these are sinking. Number two is sinking cold plumes of magma. And number third is the lateral plumes. So see what lateral plumes do. It moves from the rising and then to sinking. From rising then to sinking. From rising then to sinking. From rising to sinking. So what happens? You will observe the pattern here that the magma is rising. This is the asthenosphere layer just below the crust. So the magma is rising from the rising hot plumes and then moving laterally and then sinking in the cold plumes. So this is the structure which you will able to observe here. So these are number three. That is lateral plumes. So this is what the uh, conventional current theory is trying to explain. Now continents are supposed here. We have two continents here. So you will find here that the continents are moving over the lateral plumes. So the lateral plumes are moving here and this direction and here this direction. So this here you will find the there is a tensional force that it is creating a tension, and this tensional force is making the continent to move apart from each other. So it is diverging. Similarly, you can see also here that suppose one continent is here, one continent here, and they are moving on lateral plumes. You can see the lateral plumes here is pushing this side. Here also the lateral plumes is pushing this side. So here you will find a compressing force. Compressing force. So these two lateral plumes are compressing these two continental parts. Compressing force. So here you are able to observe the convergence. So you will observe that here we are able to observe the divergence because it is moving like that. So here we are able to observe the divergence, and here it is moving like that. That is compressing, that is coming together towards each other. So here we will find convergence. So this is how the continents moved on using the conventional currents. So this was the real force, these conventional currents, that is this tensional force of conventional current and compressing force of conventional current were the real force which made the continents to drift apart and come together to each other. Okay, so this was the force responsible for the continental drift which was explained in conventional current theory. So I hope with the help of this diagram you are able to understand the concept. So this was all for today, and in the next video you will be we will be giving an idea of sea floor spreading theory, which will be also dependent on it only. Okay, so that is all for today. Have a nice day. Thank you.